So how do we solve a log equation? Well, our goal, if we had a really simple log equation, we would use the definition. So if you had log 2 of x equals 3, and you don't have to write this one down, and I'll put the steps for solving a log equation. But if we had a really simple one, we could use the definition of a logarithm and say, I know that the basis to the exponent is 3 is equal to x, and all of a sudden this equation is super easy to solve. And this will be the key thing, is if we can use our definition to change from log form to exponential form, then we'll be able to solve for it easily. Then we can just use our algebra. So this is going to be the key step as far as solving log equations and writing all the steps. In order to use the definition, we need to have a single logarithm. So step 1 is to write all the logs as a single log. Because once you've written it as a single log, then you can use your definition of a logarithm, and step 2, change it to exponential form. And once it's in exponential form, you'll be able to solve for x. Unlike the exponential equations that we've done, where you plug it into your calculator and check to find out that it works, usually log equations are non-calculator, and after you solve them, the last thing you have to do is check for extraneous roots. Why? Because you can't take the log you can't take the log of a negative. So sometimes you'll get an answer, and one of your answers will be x equals 5, but when you plug 5 back into the original equation, the equation might have been 3 minus x, and you plug 5 in, 3 minus 5 is negative 2, and you'd have a negative number inside of a logarithm. And then that would be an extraneous root. Again, an extraneous root is a root that appears to be an answer, but when you actually check it, it doesn't work. So our goal for solving log equations is to change it to exponential form. The only way you can change it to exponential form is if you have a single log. So your first step always is to look at your equation and use your log laws and say, is there a way that I could combine things as a single log? So way back in 5.5 or 5.6, when we were practicing combining things as a single log or expanding things, now we can see where those come into effect, because solving these types of equations require us to have skills in those kind of manipulations. So in the first one, we have two logs. They're both on the same side of the equation. We've got log 3 of 9x plus log 3 of x. Could you combine those together? Is there a log law that lets you put those together? Yes. So what is the log law? If we're adding, what can we do inside of the log? We can multiply. So it'll be 9x times x. You could write that as 9x squared if you'd like. But now that we've written it as a single logarithm, now we can use the definition of a logarithm and change it to exponential form. What's the base? 3. What's the exponent? 4. What's the answer? 9x squared. 3 to the 4 is 81 divide both sides by 9. And so now we're just using algebra to solve for x. Square root both sides, and we get x equals, oops, divide by 9 and get 9. We get x equals plus or minus 3. So now that we've solved for x, the last thing we have to do is take both of our answers, x equals 3 and x equals negative 3, and plug them back into original equation. So when I go back here to the original equation, and the only thing I'm looking for is if I plug that number in, do I have log of a negative number? So when I plug in 3, can you see that you would get 27 here, 9 times 3, and you would get 3 here? Do we ever have a negative number in either of those logs? No. So 3 is good. If we try negative 3, if you plug negative 3 into this one, you get negative 27. You don't even have to check the other one. As soon as you get a negative in there, you can go down here and put an x through that one because that root is extraneous. And our only answer is x equals 3. Okay, ones that we can do for practice. Are 3, 4, and 9.